What's up, guys? It's your boy Leetcode, and this is Leetcode 2147. Number of ways to divide a long corridor. So, along a long library corridor is a line of seats, blah blah blah. Okay, here, let me just get to the important part. You have a string corridor with S's and P's. S is a seat and P is a plant. And you already have a room divider, or you already have room dividers from 0 all the way to your end of the string, right? And so basically what you want to do is, you can install additional room dividers, blah blah blah, and at most one divider can be installed in between each index, right? So you can install a divider here, 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 whatever, if you want to, but we need to do it in context of this problem because we have to do valid divisions, or we have to put a divider in valid places. So divide the corridor into non-overlapping sections where each section has exactly 2 seats with any number of plants, right? So the plants, they don't really, well, they matter in terms of the solution, but like we can put a divider here, or we can put it here, or we can put it here. The plants don't affect anything, right? There may be multiple ways, blah blah blah. 2 ways are different if there is a position with a room divider installed in the first way but not in the second way, right? So yeah, you can have one here, you can have one here, you can have one here, and no, there you have 2 seats here and 2 seats there. And yeah, we're just trying to find the number of ways to divide the corridor and return it modulo 10 to the 9 plus 7. So yeah, oh, and I'm not gonna lie, I did get a buffer, or not buffer overflow, integer overflow, because I didn't do this, I didn't focus on this. But yeah, and if there's no way to divide or put any, if there's no way to divide the corridor given this condition, you just return 0. So that's why, let me just scroll down, here you return 1 because the only way to divide the corridor is the way it's already divided. That's just one way, right? You don't install any additional drivers, right? If there's only 1 seat, you can't do anything. You return 0 because it's always going to be invalid, right? And so I'm actually going to go through some more test cases. Like, for example, this is the general, but let me just do like a bunch of peas, right? Just a bunch of plants. This, you can't put any dividers here because note the following. There's no seats, right? And it can also be like this as well, like just a bunch of plants and only 1 seat and a bunch of plants. Or this can also be no plants as well, right? It's just an arbitrary number of plants to the right and left. This is going to be 0 as well because, you're not going to have 2 seats in between the dividers, left and right. And so, yeah, you just return 0 for these cases where your number of seats is less than 2. And then, yeah, if it's just 2, as explained earlier, you're going to have like that. And then this, right? With this, when it's 2, you can have an arbitrary number, but you can't divide this anyway because there's already 2 seats, right? You can't put a divider anywhere here. So yeah, there's just gonna be 2. Now I'm gonna go with I'm gonna show the general case, right? And so I wrote some of this out, and I just want you guys to note the following: that okay, look at this substring, right? You need to look at first look at this substring. 1, 2. So yeah, look at this right here. I'm just gonna let me do it with a different color, or with the highlighter tool. Okay, so yeah, this substring, right? And note the following: there's 2 S's, so you can only divide this one way, right? You can only do it once, and it is, by not installing any additional dividers, right? And in fact, here, let me draw out the dividers here as well. Different color, like, I guess this is a good color. Let me just already put those dividers there. And yeah, so next I'm going to look at the substring right here. And so yeah, note that the number of ways that you can divide this is going to be, wait, did I do in the right position? Yes, I did. Yeah, there's 4 seats, right? Actually, you know what I'm gonna do? I'm going to write the index, right? So let me just do this. 0, 1, 2, 3, 4, and 5, right? Just so that it kind of looks like this bottom schematic or whatnot that I did. But this is going to be n2 plus 1, right? And here's why. You can put a divider here. Let me do a different color. But yeah, you can do a divider here. Oops, my bad, guys. You can do a divider here. You can do a divider here. Blah blah blah, all the way to, that's gonna be n2 dividers from here to here, and then you can do another divider here, and that's n2 plus 1, right? And notice that in all these dividers, you're still going to have 2 seats here and 2 seats there. And so let me just, so yeah, you in this, it will be n2 plus 1 with of course modulus, let me just do this, mod 10 to the 9 plus 7, right? Because we don't want to whatever overflow. So that's going to be for that string. It's going to be that. And then one more substring here. Let me do this. Oops, my bad. Ooh. All right. Then one more substring. We're going to have the entire string as our last substring. And this is going to be an important observation we make, is that you need to put one partition in like somewhere here. It needs to be somewhere here and somewhere here, because you need to have exactly 2 seats in between each divider, right? And so there's 2 here, there's 2 here, and there's 2 here. So you need to put one of your dividers in here and another one of your additional dividers in here. And so note, by our substring, there's like n to 2 plus 1 places we can put it here, right? So there's n to 2 plus 1 places that we can put our divider in here. And so what you're gonna do, okay, so I put one divider here, and then you can put n to 2 plus 1, right? So that's n to 2 plus 1. Oops. Then you put another divider here, that's n to 2 plus 1 again. So that's gonna be 2 n to 2 plus 1. And you do that n to the 4 times, or n to the 4 plus 1 times, and you're going to get to the end here, and you're eventually going to get this, right? N to the 4 plus 1 times n to the 2 plus 1. You're eventually going to get this, right? And so, note the following, right? You can continually do this, and you're going to trend to the following solution, right? It's going to be your number of ways, and remember the modulus stuff that I was explaining earlier, but the number of ways that you can divide like a string with like m seats, right? So let me just go down here. So suppose you're gonna have something like this, right? And then right, this, and make sure that this is even, because as explained earlier, I don't know if I explained this, but yeah, in the case where you have an odd number of seats, I guess I should have explained, but yeah, an odd number of seats, so like 1, 2, 3, you have a bunch of p's, there's odd number of seats. There's no physical way to divide this such that there's 2 seats in between every corridor, right? Because you can't put it here, you can't put it anywhere, right? You're still gonna have like 1 seat here, and so you can't, this doesn't work, and your number of seats needs to be even. and then yeah, this, then you analyze this. But yeah, your number of seats does need to be even, otherwise you need to return 0. But for this case, let me just do this, and then this is gonna be n0, and then this is gonna be this is gonna be n1, then this is gonna be like whatever in between. This will be your in between whatever, and this is gonna be n to the m minus 1. I think. Let me check. No, it's gonna be n to the m. Yeah, it will be n to the m because of like how I formatted this. Whatever. It's going to be because if it's n, the one before is going to be n, like this before to whatever s. This would be n to the m minus 1, right? But yeah, this is n to the m. So basically, the solution you trend towards is going to be n to the 2 plus 1. We write it in black. It's going to be n2 plus 1 times n4 plus 1, and then dot dot dot, n to m minus 2 plus 1, right? This is the solution that you trend towards too. And let me just write it out in little infinite product notation, or not infinite product, your product, like, you know, I forgot the name of it, but k equals 1 to m minus 2, I think, or no, it would be m minus 1, I think. Would it? No, it would be m over 2. Ooh. Then you're gonna have n to the 2k minus 1, wait, there, n to the 2k plus 1, and then you multiply it. Wait, let me just see. Over 2, yeah, it will be this is correct. So yeah, this is gonna be your solution, of course, but you do need to do your modulus or whatever, get the number mod 10 to the 9 plus 7. And so let me just go through the code real quick, all right, that I wrote. And so yeah, you know, you have your modulus, you got your corridor, count your number of seats, your return value, and yeah, this I stored it in an array called plant count to count the number of plants. And yeah, the reason why I made it size n is because, you know, it's going to be at least like n, right? Like it's a safe upper bound, just a very safe upper bound. So yeah, you know, you just go through the corridor. If there's a seat, you increment the seat count. Otherwise, your plant count, you know, it's indexed kind of like how I indexed it here, right? So plant count of 0 is going to be this, like the number of plants here. Plant count of 1 is going to be this, and then plant count of m is going to be this. Plant count m minus 1 is going to be that, right? So let me just go here. And so yeah, you just increment it for every plant you see, because, you know, yeah, this is where your plants, yeah, whatever. And so, you know, these was the edge case. These are the edge cases that I was explaining earlier. If it's odd, you return 0. If it's less than 2, you return 0. And if it's exactly 2, you return 1. And yeah, this code just essentially computes, and it takes the modulus into account. You know, you take this mod 10 to the 9 plus 7. Actually, I don't even think I need this. Let me test that out real quick. I don't think I need that modulus right there. Submit it. Yeah, okay, so you don't even need that modulus. But yeah, you need this one. And you need to make sure that if you don't make this long, you're actually gonna get integer overflow. I'm gonna show you guys real quick. Or assigned integer overflow. Yeah, see? So yeah, this needs to be long. Or I don't know, can also be long. Let me check this. Just long. Yeah, okay, so it can also be just a long, but you know, I'm gonna keep it as how I did originally. But yeah, you compute. Note that yeah, this is gonna be from I equals 2 all the way to I equals seat count minus 2 is going to be your last index, because I'm just going by 2's here, so that I follow this formula that I wrote out. So I follow this. And so, yeah, essentially, yeah, this is going to get your return value. Remember the modulus, and yeah, this is essentially the solution that I came up with. I don't know what the editorial did, because I'm not gonna lie, I didn't read it. But I'm guessing they did something similar. I guess I'll check real quick. Okay, blah blah blah. Yeah. Okay. So, yeah, just show me the code, bro. Sheesh. And okay, I don't know. Is this a dynamic programming? I don't know what the heck they did. This. So, looks like they kind of overcomplicated it or something. Yeah, I guess they use a dynamic programming type of solution or something. Yeah, bottom up. Or wait, so they don't tell me what type. Okay, but yeah, that's the solution they came up with. This weird little tree, I guess, recursive little tree, and then yeah, they just did dynamic programming. Okay, and then they did combinatorics, I guess. Yeah, blah 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 blah, and it's all O of n. Yeah, it's all O of n, but yeah, they did a little combinatoric solution as well. Good to see. And yeah, so thank you for watching. And keep doing your Leetcode, whatever. Peace.